Hey guys, in this video we're going to take our first look at factorising, solving and also, because it is not drastically difficult at this stage, sketching cubic graphs. So we're going to be factorising expressions, then solving the equations and then sketching the graph. We're only going to include though the points where the graph gets the x-axis for now. So we're going to be dealing with cubics, where we only have ax cubed plus bx squared plus cx. So there's no constant term at the end. So before we get to those, which are slightly trickier, we're going to we're going to need to make a couple of new friends in the factor theorem and the remainder theorem, which we'll do after this, and then we'll come back and do some more stuff like this with trickier cubics. So, when we are factorising and solving cubics in the form ax cubed plus bx squared plus cx, then x is always a factor of these. So we can always factor out an x. So if we do that, ax cubed plus bx squared plus cx can become x lots of ax squared plus bx plus c. Now this x on the outside gives us one of our solutions straight away to make the equation true. To make it equal 0, x has to be 0. So what's going to happen with all of these? They're going to pass through the origin or the point 0, 0. So taking out that x, that's a linear factor, which then leaves us with a quadratic factor. Now this quadratic might be factorisable and give us two more distinct roots. It might only give us one more root, or it might give us no real roots. So again, the discriminant is going to come in handy here, and all of our quadratic skills that we've learned up to here. So let's go through some examples. Okay then, first up we have x cubed minus 7x squared plus 12x equals 0. Now, first of all, let's only worry about this as an expression, then we'll worry about it as an equation. So, if we're only worrying about the expression, we are only worrying about that part. So, we have a common factor of x, good times. Now we can take this out and factorise this a bit. So we've got x times x squared minus 7x plus 12. So we've already got one linear factor, which is our x at the start, and then we've got a quadratic factor of x squared minus 7x plus 12. Now while we're doing these, I'm going to practice using the discriminant again, because it's good practice and also guarantees that we don't spend unnecessary time searching for solutions or factors that don't exist. So, this quadratic is easily factorisable, but let's prove it. First of all, using the discriminant. So, the discriminant, remember, is b squared minus 4ac. So, minus 7 squared is 49. So we got 49 minus 4ac. So 4 times 1 times 12 is 48. So 49 minus 48 equals 1. Now when the discriminant of a quadratic is greater than 0, that implies 2 real roots. So there are 2 roots, as we probably knew. So how can we factorise that quadratic then? Well, it's going to be x minus 3 times x minus 4. So what we've now done, we've factorised the expression. So if we now go back to thinking about it as an equation, then we've got this factorised expression here is equal to 0. Now, we've got 3 real roots. So, the first one, this x tells us x is equal to 0. If x is equal to 0, we got 0 times the first bracket times the second bracket. 0 times anything is 0. The second bracket tells us x equals positive 3. And the third bracket tells us x equals positive 4. I like that. So, congratulations guys, we've just factorised and solved our first cubic equation. So, as I said, I'm also going to include a sketch, because it's good practice and not ridiculously hard yet. So, what we've just worked out then, we've just worked out points where the graph cuts the x-axis. Now, it's probably just going to get better if I draw the curve first of all. So, how do we know whether the graph is positive or negative? Well, they work sort of a bit like straight lines. If the x cubed term is positive, then we start in the bottom left. So the graph's going to start down here somewhere, and it's going to end up over here in the top right part of the graph. So we know it goes through the point where x is equal to 0. So it's going to go through this point. We know it goes through the point where x equals 3. So it's going to turn around like that. And then it goes back up through the point where x is equal to 4. So it's going to look something like that. So if we zoom in here, okay, that hasn't gone straight through. So it should have gone through that point there, where that's 0, 0. This point would be 3, 0. And this point over here would be 4, 4, 0, like that. So, there's a sketch for a graph. We're not going to worry about the coordinates of the top and bottom of those curves in the middle, or I should say the crust and the trough. So we're not going to worry about those yet. We'll worry about those later on. But there's a sketch of our very first cubic. Okay, next up we have minus x cubed plus 5x squared minus 4x equals 0. So, this time it's important to note we have a negative x cubed term. So that's going to do something slightly different with our graph. Now, given that we have a minus x cubed term, we could just factor out an x, but we could do one step more and factor out a minus x. Now, what that's going to do, it's going to reduce the power of x of each term, as before, but the negative part is going to flip the signs. So it's going to leave us with a positive x squared, which makes it easier to factorise. So, when you take out a factor of minus 1, anything negative becomes positive, anything positive becomes negative. So we'll be left with a positive x squared minus 5x and then plus 4 at the end, like that. So again, we're only worrying about it as an expression, first of all. So we'll factorise and then worry about it as an equation. So, let's use the discriminant to check how many roots we're looking for in the quadratic. So here the discriminant is minus 5 squared, so positive 25, minus 4 times 1 times 4, which is 16. So we got 25 minus 16, just going to leave us with positive 9, like that. So that implies 2 roots. Okay. So if we factorise this, we got minus x times, well, we want a minus 5x and a positive 4 at the end. So it's going to be x minus 1 and x minus 4, like that. Now, if we think about this as an equation, we got an equals 0. Now we can think about our roots. So, as ever, this x term, even though it's a minus x, still tells us x is equal to 0. Second bracket tells us x is equal to 1. Third bracket tells us x is equal to 4. Good times. So we've factorised, we've solved, let's sketch. So remember, we have a negative x cubed term this time, so our graph starts up in the top left. So it's going to go something like, well, it goes to x equals 0, let's try not to miss it, good times, then it's going to go up through x equals 1, then it's going to go back down through x equals 4. So this point is 4, 0, this point is 1, 0, and this point is 0, 0. So that graph looks slightly different to the ones we've had before, and it's because we had this negative x cubed term. Good times. Okay, next up we have x cubed plus 2x squared plus x equals 0. So, as ever, let's just worry about the expression. First of all, we have a factor of x. Let's take that out. So, if we factor out x, we're going to get x squared plus 2x plus 1. Now, let's check that quadratic to see how many roots we are looking for. Again, if you can spot it, that's absolutely fine. I'm just using the discriminant because it's good practice. So, discriminant here is going to be 2 squared, so 4 minus 4 times 1 times 1. So we're going to be there. So it's going to be 4 minus 4, which is 0. So, when the discriminant is 0, we have 1 real root. So, this cubic is only going to have 2 roots. So, can we factorise that quadratic? Yes, we can. It's going to be x plus 1 times x plus 1. Now we can write that as x lots of x plus 1 squared. You don't have to, you can if you want to. So, if we now think about these as being equal to 0, as I said, we're only going to get 2 roots. So, this tells us x is equal to 0. The brackety bit, x plus 1, tells us x is equal to minus 1. Like that. So, what's this graph going to look like then? Well, it's a positive x cubed called our cubic. So, it's gonna start down on the bottom left. Now it's gonna start down here, and it's gonna end, because it's a positive x cubed, it's gonna end over here in the top right. Now, how can it go from the bottom left to the top right, but hit the x-axis twice. Well, what's going to happen, remember with quadratics, when they have one repeated root, and they hit the x-axis, they either sit on it, or they hang off of it. So this guy's going to hang off of it. So it's going to go something like that. So it's going to hit the x-axis over here at -1, 0, and then it's going to go back down, but then it's going to go up through the point 0, 0, like that. So there's our sketch to our graph. Jobs are good. Next up then we have -x cubed plus 4x squared minus 4x is equal to 0. So, as always, let's only think about it as an expression, first of all. So, again we got a negative x cubed. So we can take out a negative x, like that. So that's going to leave us with a positive x squared, a negative 4x, and a positive 4, like that. Oh, sorry, we're only worrying about the expression, getting carried away. Okay, so let's check the discriminant. So the discriminant of the quadratic is going to be -4 squared, which is 16, minus 4 times 1 times 4. So it's going to be -16, which is 0. And that implies 1 real root. So we're only looking for 1 root in the quadratic again. So we can write this as -x. Lots of, well, it's a perfect square quadratic then. So it's going to be x minus 2 times x minus 2. Which, if we want to, but we don't have to, we can write as -x times x minus 2 squared. So if we now set the expression equal to 0, either one of them, well, the solutions to this bad boy are going to be, this bit tells us x is 0, as always, and then the quadratic part, or the repeated linear root, tells us x is positive 2. So there are our 2 roots. Let's have a little go at sketching it. So this time we have a negative x cubed term. So our graph is going to start in this bit and it's going to end in the bottom right. So how can it hit the x-axis at x equals 0 and x equals positive 2, such that it starts in the top left and ends in the bottom right? Well, it's going to have to go something like this. So it's going to have to go through the point 0, 0 and then go up, hitting the x-axis x equals 2, and then carry on going down forever and ever. So coordinates for this point are 2, 0, coordinates for this point 0, 0. Good times. Okay, now we're moving into slightly trickier ones, so we're not going to worry about sketching now, we'll just worry about solving. So, 5x cubed add 2x squared add 3x equals 0. Well, let's think about it in the same way. Let's just worry about the expression first of all. So we can factor out an x, and then write the rest as 5x squared plus 2x plus 3. So that's not looking like a very nice quadratic factor. So let's find the discriminant. Here the discriminant is going to be 2 squared, so 4 minus 4 times 5 times 3. So that's going to be 4 minus 4 times 5 is 20 times 3, so we got 4 minus 60, which is minus 56. Now a negative discriminant tells us that there are no real roots. So if there are no real roots in the quadratic factor, that means our only solution to this cubic, so the only solution comes from the x part, so the only solution is x equals 0. So the cubic only hits the x-axis at x equals 0 and never again. So, as I said, then we won't worry about the sketch here. Okay, last example for this video then. If anyone wants more like this, let me know down below in the comments. So, 2x cubed plus 8x squared equals minus 3x. Now there's a bit of a twist in this one, and not everything is on the same side together. Again, you might be tempted to divide through by a factor of x, but don't do that because you will lose the solution. So, first of all then we want to add 3x to both sides. So we got 2x cubed add 8x squared add 3x is equal to 0. Now, it's time to factorise the expression. So we got x lots of 2x squared plus 8x plus 3. Now, can we factorise this quadratic? Well, let's first of all find the discriminant to see if there are any roots. So, the discriminant is 8 squared, so 64, minus 4 times 2 times 3. So, we've got 64 minus 4 times 2 is 8, times 3 is 24, 64 minus 24 then is 40, which is positive, so the quadratic does have 2 real roots. So, now annoyingly we can't factorise this guy, so we're either going to have to use the formula or completing the square. So, what I am going to mention, first of all, we've got our first solution. We've got our first solution from factorising it this far is x tells us x equals 0. It's one of our solutions. Now to get our other two, I'm going to complete the square on the quadratic. So, remember we are solving 2x squared plus 8x plus 3 is equal to 0. So, I'm choosing to complete the square here because I hate using the formula. Now, because this is a quadratic equation and not just an expression, we can divide through by this 2 attached to the x squared. So that would leave us with x squared plus 4x plus 3 over 2 is equal to 0. Now if we complete the square, we would get x plus 2 squared minus 4 plus 3 halves is equal to 0. Now that's going to give us x plus 2 squared minus 4 plus 3 halves is, well, minus 4 is minus 8 halves. So we got minus 8 halves plus 3 halves. That's going to give us minus 5 halves, like that. So that's equal to 0. Now we've got x plus 2 squared is equal to 5 halves. If we square root both sides, x plus 2 is equal to plus or minus the square root 5 halves. Then finally take away the 2. X equals minus 2 plus or minus the square root of 5 halves. So we then got our 3 solutions. X is equal to 0. X is minus 2 minus the square root of 5 halves, and x is minus 2 plus the square root of 5 halves. Jobs again. Okay guys, hope you found this useful. Next up, we are looking at the factor theorem.